Good morning.
Hey, everyone.
Hey, here we are, just, live in 181.
There we go. Hanging out.
Yeah. We're going to do a little bit more with the periodic table, so what better background than
The periodic table.
right on.
Yeah.
Okay. So today we're talking about valence electrons and how the periodic table can be very helpful.
Very useful. A lot of information.
Yes. So let's just dive right in, shall we?
Let's.
Okay, so as a review, all right, we're talking about the groups. Now, this is very important when we're talking about valence electrons. And groups go which way, Mr. Wood?
Ooh, they go up and down. They're columns, right?
Right.
And columns go up and down.
Got it.
Okay.
So as you can see on your little diagram here, they are color-coded so that you can see them.
Roy G. Biv style.
Roy G. Biv, yes. And we're going to use those as our important groups for valence electrons.
Excellent.
Okay? So remember that each column represents a group. They all have similar properties. Okay? And then remember, too, that going across each period is dealing with the amount of energy levels an atom has.
Okay. Yes.
So far, so good.
So everything in the same period has the same number of energy levels.
Right, or rings, or shells, or
Whatever
clouds,
you want
whatever
to.
you would like to refer to them
Okay.
as. All of the above will work.
Excellent.
Okay. Now, in the groups, what's really cool about these groups is not only do they share properties, but they have the same amount of valence electrons.
That's very cool.
Do you know what a valence electron is?
No idea.
Okay, valence electrons are the ones that are the furthest away from the nucleus.
Okay, so you're saying everything in, let's say, group 9, they'll have the same number of valence electrons.
Correct.
Wow, cool.
Pretty easy, right?
Yeah, that's nice.
Okay. Or anything in group 13 has the same number of valence electrons. Again, these guys in the middle kind of are a little
bit weird.
tricky.
Okay.
Yeah, but we're going to stick to the main outside.
So we're going to skip these guys, right? 3
Right.
through 12.
Mm-hmm. Like, there won't be a test question that says, hey, how many does iron have? We're going to avoid that.
Okay.
But for future reference, most of these will have around 2-ish.
Ooh, ish.
You know,
Ish.
Because there's always that one case
Ish,
of
you know.
something. So, all right.
Crazy, crazy.
So, let's take a flashback, and if we can remember, the Bohr model,
Ooh,
if you will.
love that model.
Okay, where the protons and neutrons are in the nucleus in the center, where
Yep,
they always live.
yep.
Okay, and our electrons are around the outside. Okay, so that first energy level contains
Dose.
two,
Two.
Spanish for two, of course. Okay, the second energy level can hold up to 8. Then we go to
18?
Then we go to
30?
yes.
Okay.
Okay. So now we'll just call the valence electrons whichever ones are the furthest away. Okay.
Okay, sounds
Got it?
good.
Yeah.
So the ones on the outer ring.
Outer ring, outer shell, outer energy level, outer cloud, whatever you want to go with. Okay. Use any synonym here. All right. So the octet rule. This is the important thing. Okay. Atoms want to have that magic number of 8. Okay.
8.
That's how they're happy.
Okay.
Octet 8, octet 8, 8, octet.
So octet 8, that's for the ones that have 8 in their valence electron shell thing?
Yeah.
Okay. So we're so we're looking at kind of the smaller-ish atoms.
Correct. Right. But they want to have, they're anxious to get that 8 in their outer shell.
Gotcha.
Because that makes them happy.
Because helium doesn't want 8.
Right. Helium and hydrogen are 2 exceptions.
They're
Again, there's
weird.
always an exception to the rule.
Yeah, okay.
Okay. So, but yes, when you say you want to complete the octet rule, you want to have 8 in your outer shell.
Gotcha. Okay.
Okay, so let's take a little look at what we can talk about here, okay? Now, we flash back to, I think, Unit 2 when we talked about ions.
Ooh, whoa.
Rewind it back
Okay,
up, okay?
okay.
Ions are something that has a charge, an atom with a charge.
Okay, so different numbers of electrons and protons.
Exactly,
Okay.
okay? If I have more protons than I do electrons, I am going to be called a cation.
Cation. Positive.
Positive, okay?
Yeah,
And
they're fun.
these are usually in groups 1 through 13, okay? These guys usually here are going to be cations. They're going to lose electrons so that they can be positive.
I've noticed they're also metals.
Yes,
That's
exactly.
kind of fun.
Okay, so all the metals, we'll say all as with a little star, asterisk, of course, okay? They are usually going to be cations. They're going to give away those electrons.
Oh, that's
They're
fun.
just a friendly group,
Yeah,
okay?
Something.
So, for example, you can see over there, I have up there is potassium. So behind you over there, number 19. Careful, don't fall off the gym. Okay.
Turn there.
So we have potassium in the atom. We'll just write it with a K. But potassium has 1 valence electron. So if it would give it away, okay, give it away now. Okay. And then we would symbolize it with K with a plus because it has a positive 1 charge.
Cool. And now, so it has 1 valence electron because it's in group 1?
Exactly. Yes.
Okay, so then group 2 would have 2 valence electrons.
Yes.
Okay, gotcha. And then we skip.
The transitions because they're kind of goofy.
Mhm.
Okay, and then I go to group 13. 13 is going to have 3 valence electrons. Group 14 is going to have 4 valence electrons. See the tie here?
Right.
Group 15?
5.
Yep.
Ooh, you like that? I got excited.
Group 16?
6.
Group 17?
Oh, I'm going to say 7.
Yep. And then group 18 is going to have that magic number of
octet,
or 8, if you will. Okay? So, our metals are usually cations. They're going to lose their electrons. But our non-metals, or in groups 14-ish and over, 14 is that funny group. We'll talk about that in a minute. Okay? These guys are going to gain electrons, so they are going to be negative.
Oh, well, that's fun.
Okay, so example over here, I picked chlorine. All right, if I wrote chlorine atom, I'd write Cl. But if it, say, gained that 1 electron from potassium, if you will, it would then be written as Cl minus.
And it would have its 8.
Exactly. And we call them anions, in case you forgot about that. Okay, good. So, here for you is a little picture.
I love
All right,
picture.
and basically what it just tells you is what group has how many valence electrons and what its charge is going to be.
Okay.
So again, group 1, 1 valence electron. So the way we look at these valence electrons and what their charge would be is, what is the easiest way I can get to 8? Do I want to gain 7 or lose 1?
Okay.
Okay?
I got you.
So, for example, group 1 has 1 valence. It's easier for them to get rid of 1 than try to gain 7 more.
So they'll get rid of that 1, and that outer shell will just be gone.
Correct.
And then they'll have 8 in the next one down.
Exactly.
Is that how it works? Okay.
So group 1 has 1 outer electron, so they get rid of that, and they will have a positive 1 charge.
Oh, look at that.
Okay.
That's fun.
Yeah. Group 2. Oh, would you like to throw a charge up here?
I would. I happen to have a post-it note with a 1 on it.
All right. So that would go over group 1. Just careful.
I'm just gonna put it right there.
Careful. Thank you.
No
Thank
problem.
you, Vanna
I'm
White.
like a cat.
Or
very good.
Victor
balance.
White will go with.
Oh, thank
Okay.
you.
Group 2, the alkali metals, if you will, have 2 valence electrons, so they're going to get rid of those because it's easier to get rid of 2 than gain 6 more.
Totally.
So they will have a plus 2
look at
charge.
that.
Look at how beautiful.
Very fancy.
Okay. Then we'll skip these transitions again, and we'll rotate. Okay. Group 13 is a group of majority of metals, and they are going to have 3. We're going to get rid of those, so we'll have a plus 3 charge.
Plus 3.
Okay. Now group 14 is where we get a little tricky,
Weird.
because when you talk about getting to 8, what's right in the middle of 8?
Well, 4 is usually right in the middle of 8, right?
Yeah. So 4 is the tricky group because you can either be positive or negative depending on if you gain or lose.
Okay. So this is probably like they'd have to be told this, right?
They'd have to be told whether it's a cation or an anion.
Gotcha.
Yes.
Okay, that makes sense.
Particularly if it's written first, it'd be a cation. If it's written second, it would be...
Okay. Or maybe if it's like bonded with a bunch of these guys.
Right,
it'll be the
exactly.
negative. Okay.
Then we jump to group 15, which they have 5. Now it's going to be easier to gain 3 electrons than lose 5. So we're going to have a minus 3
So
charge.
once again, gaining 3 means it's a negative
Negative.
charge because you're gaining negative.
Gaining negatives, yes. Okay. Then we go into group 16, which will have 6. So we're going to be easier to gain 2 outer or valence electrons to give us a negative 2 charge. You're doing a great job, Victor.
You know what? I feel so useful.
And then group 17 is going to have 7, and it's going to be way easier to gain 1 than it is
You
to
know
7.
it.
So we're going to be
know it.
minus 1 charge.
There we go.
Okay? So that's what your charges would look like, and then group 18 we just kind of leave because it has 8.
So it would
Except for helium. Helium has 2.
So it would have a 0 charge. Right?
Yeah.
So really
Neutral,
yeah.
yeah.
Neutral.
So,
Gotcha. Okay.
Okay? So here's what I'm going to do. I'm going to flip through these, and we're just going to take a little practice. How many valence electrons do you think aluminum has?
It's this one right here.
Oh.
Let me move up that post-it a little bit
Okay.
so you can see what the column number.
Okay, so if I'm in group 13, I'm going to go with
Ooh,
3. Perfect. Okay? What about if I skip over here to barium?
Barium.
As you can see with my very shortness, it's in group 2, so that would be how many?
I'm going to say 2.
Good.
Just going out that. Oh,
Okay.
Whoa, whoa.
I flipped all the way over to bromine.
Oh, look at that.
Who's not
Right
your
there.
brother? Mine. Your brother, mine. Kenny?
Oh, no.
Okay, it's not a very good joke.
No, that's hilarious.
Group 17, and we have 7, so we're going to be 7 valence electrons.
sorry.
Yes. My bad, I jumped ahead.
That's cool. Didn't
Okay.
leave me alone.
Then here we go to arsenic, AS. It happens to fall into group.
15.
So we have how many valence electrons, Mr. Wood?
I'm going to say roughly 5-ish.
Perfect. Okay, and that's about all we got. You're going to practice more in class, and see you later.
Yeah.
Bye.